Thanks, Robert. So this is a little odd because you guys may or may not be able to see me, and I certainly can't see you. So this is like talking into the abyss. So with that, I'm going to do about 20 minutes of discussion today about some work, about data centers. And just to give you a little bit of introduction and background about myself, and my name is Paul Ehrlich. I have my own consulting firm called Building Intelligence Group. I live in Minnesota. I've worked with the BAS Center with Peter, since before it was the BAS Center, probably for the last 10 years, largely doing a lot of research and background work on various different efforts and issues that have come up with the BAS Center. But my day job, my background, my experience is I'm an engineer who is involved in commercial building energy efficiency. My background and expertise is in controls and integration. I served on the BACnet committee and I've worked for various different manufacturers and with numerous owners in doing control systems implementations and upgrades as a consultant. With that said, I will give full disclosure here. I am not a data center expert. I've done some work involving data centers, but I'm not somebody who's regularly involved in the design and commissioning of data centers. I did send 2 pieces out, which I believe Robert has printed out and provided in your packets as pre-reading or post-reading if you prefer. One is a case study that we did probably about 10 years ago as part of a series of case studies about building operations. We did 4 or 5 of these, including one about the Smithsonian, and one about a cancer research center, and another one about Adobe. This one was on a data center focused one, and I had the opportunity actually to go out and do some of the field work on this at an eBay data center that was located outside of Salt Lake City. So it's a little bit of background overview of some of the issues for a Tier 4 data center. The other piece is kind of an interesting piece. It's an article that is written by a researcher from Mars Berkeley National Labs. I'm one of the co-authors on this. And it's an interesting case study because it talks about what I'm actually largely focused on these days, which is a new project that we're doing to create an open standard controls description language. And it's if you think about a controls description language, it's a graphical programming language like automated logic icon is an example of one. But this is an open standard to do this. It's done in an open language called Modelica, and it allows us to create control sequences graphically in a way that's open and interoperable. They can be tested in the design process using the Modelica modeling language. They can be used for highly accurate energy models, and then they can be readily translated for deployment on commercial control systems. So my main project these days is I'm leading an ASHRAE project called ASHRAE Standard, a proposed standard 231, a control description language, and we are meeting regularly to create this interoperable standard. And we're getting ready to put it up for public review probably later this year, so we've been working for a few years on that. But with that said, I'm going to go and talk a little bit about data centers, and I'm going to start by talking about the basics. And when we think about data centers, we can kind of think about the primary purpose is to do in the data processing world we call this the server side processing. So I'm sitting here running Zoom right now on my browser, which is the client side. But to make this work, something's happening up in the cloud in a Zoom data center or Amazon Web Services data center to make all of this happen, and that's the server-side processing. The data centers come in various different scales and sizes, but we're going to talk today about big data centers. These are the dedicated facilities like the one that you're going to see later today. And some of these facilities are owned by an organization. The case study that I sent you was owned and run by eBay. It was theirs. You'll see data centers that are owned and run by various different tech companies like Amazon, Apple, Google, Facebook, IBM, all run their own data centers. But more and more often, banks often run their own data centers. More and more often, we're seing things that are shared, and they can be either what are called co-location or colo, where you basically have a server or a rack of servers or a section of servers or the ability to run your application out of somebody else's servers, or they may just be cloud data centers. And Microsoft Azure and Amazon Web Services, AWS, are two examples of this, where you just say, hey, I've got this application, it needs to run in a Unix box, and I want to buy capacity to run this on 10 cores for the next hour and a half, and boom, it runs and you pay, and that's it. So you see a lot of things today that are either cloud functions or they're enterprise functions or co-location functions. And things that run in data centers are wide and varied, an incredible amount of financial stuff, search, cloud computing. There's a lot of applications today for cryptocurrency and Bitcoin mining, all are done in these big scale data centers. One of the terms and one of the most important things that we think about when we think about data centers is this concept of reliability or uptime. And this is the concept that drives, I bring this up because this drives everything that has to do with the mechanical and electrical systems that deal with these centers. So that in the industry, they talk about 4 tiers, with tier 4 being the most reliable and having the most uptime, and tier 1 being the less reliable and the lowest uptime. But these really drive the amount of redundancy, and you'll hear in the industry they'll talk about N being regular reliability, N+1, N+2, or 2N. So this talks about how redundant the electrical systems and the mechanical systems are. And when you take a look at the center today, you'll see that they'll likely have multiple redundancies. So the whole design is around, if one thing fails, it shouldn't bring the data center in. In the case, by the way, of the eBay data center, when we went through that in 2012, that was it was being built in several portions. The portion that we viewed was a tier 4 data center, the highest uptime, because at that point they owned PayPal, and they were doing a lot of financial transactions through there. They were getting ready to build the next piece of that, which was going to be the tier 2 data center, less crucial, and it actually was not going to have any backup power on it because it wasn't necessary in the tier 2. So that drives a lot of the design and the functionality. The other thing that's important in data centers, obviously, is capacity, because the real estate's expensive. You want to get as much computing as possible. So there's a lot of pressure to move more and more data processing, more and more flops or teraflops of data into as little space as possible. So you see a couple of things that have been done to this. One is that most data centers no longer have servers in them. They now have what are called blades. They're instead of being a box with a CPU and the fans and everything else, it's like a little slip-in piece that fits in the capacity of where a server used to be. You might see multiple blades in that. And that just gives you higher density. And it also allows you, if one of those fails, to pull it out and rapidly replace it to minimize the downtime. Almost everything in the data center that you will see is stored on racks. The racks include all of your networking gear, they'll include all of your servers, all of your storage, and everything else. In the back of the rack, you'll see a giant plug strip. Being a data center, they can't call it a plug strip, it's called a power distribution unit. But the way this works today is many of these racks, they'll come in from a vendor such as Dell or HP or whoever, and the owner will just they'll lease that rack. So they'll get it as on a 3-year lease, and at the end of 3 years, they roll that rack out and it goes back to the supplier and they get a new rack in. And that way they always have the best and latest and greatest. But the reason I bring up this processing issue is the result is that we are seeing more and more watts of energy being packed into a rack all the time. So that means we need more and more cooling and more power in a higher and higher density. Server room, is a dedicated, generally highly secure space for processing. And as I mentioned, everything is racked in here. So the servers, the blades, the storage, the networking. But it's designed so that racks can come and go and readily be changed. There is a lot of cabling required, both power cabling and network cabling. And depending on the data center, that cabling may go in a raised floor, it can go underneath the racks, or it may go overhead. If they're using raised floor, they may also use that raised floor for air distribution as well. One of the big changes that's occurred in server rooms and in data center design over the last 10 years is a real change in how they're cooled, always cooled. It used to be, if you walked into a data center 10 years ago, it was you would see a raised floor, and you'd see racks set up on the floor, and the air would just be swirling around everywhere, and it would be really cold. I remember going to data centers years ago, it was 60 degrees, and everything was cold. But when you started looking in the racks, everything was pretty hot. That's pretty uncommon for a data center today. Most new sites now are really using what they call a dedicated hot and cold aisle. In fact, you'll see curtains that will go from the racks up to the ceiling now. You'll see sliding doors that will go on the hot and cold aisle, and you'll see that they're actually actively forcing that air from the cold aisle, or from the cold aisle rather, where the air goes through the air handlers, and gets cooled down by the chillers, and now it's being forced through the rack in an intentional way, and it's coming out the hot aisle. That's a big fundamental change. It's improved the efficiency tremendously of data centers. It's allowed for better cooling capacity, and it's allowed for a whole change in mindset around how these areas are conditioned. If you talk to an IT guy 10 years ago, they would tell you that data center's got to be 60 degrees, or else the equipment would be destroyed. Most data centers today are running with hot aisles up to the 85, 90 degree range, and some of them are running with cold aisles at 60 or 70 degrees. So the case study that I sent you is using those assumptions of a very warm cold aisle and a very, very hot aisle. If you can do that, then what you need for cooling changes dramatically. And in the case study, if you read through that case study, which is simulated in Sacramento, I believe, I think there's 8 hours a year the majority is true, and the rest of the time, that data center, at least in theory, can be cooled just using an evaporative cooler from a cooling tower. Systems, I always like to think in terms of systems. Power, obviously, is critical, and it's probably, the data center person's mind, one of the most critical thing. It depends on the tier, but generally, most data centers will have redundant utility feeds, and that means that the utility will be providing 2 different electrical services or more. Each of those will come from a different substation. So if you have a utility failure due to an outage or something that's down, generally that will automatically switch over, and it will be served from another utility feed. So N is the one, N plus 1, and then there's N plus 2 is your emergency generators. And most data centers that you can look at will have an entire area that's just completely filled with diesel or natural gas powered generators, and they'll generally be able to run for an unlimited amount of time on generator. In addition to that, the power generally will go through a UPS for power conditioning, and for even have some short-term battery backup capacity as well. And then you'll see a lot of switching, because the system is set up so that anywhere along the line you can get power from feed A, feed B, or from emergency generation. So you'll see lots and lots of switching and power conditioning. The IT gear uses a lot of power. It's not like the laptop that you've got at home or the computer you have at home. Most of the servers today are running on higher voltages, anything from 120, but many of them are running on 208 or 240 volts. The power generally comes in the back of the rack, as I said, through this power distribution unit. Power distribution units are often smart devices, and they often can monitor the health of the rack and the power conditioning and do metering. And I've worked on projects where the PDUs are also controllable, so we can actually control capacity and what's running based on what's going on in the PDU. There is also a shift going on in data centers, and this is not. This is more experimental and widely being used away from the use of AC power to DC power. Basically, everything in the data center is a DC load. All of your servers, all of your networking gear, all of your storage is not actually an AC load, but a DC load. So there is a lot of interest in tentative work in shifting them over towards DC power distribution. That's a research area right now, probably more so than broad implementation. But particularly if you have, if you think about a data center that has some renewable energy, that's also a DC thing. So it's interesting to shift over to DC power. HVAC, heating, ventilating, air conditioning. Generally, most of the data centers that you look at are going to have some type of dedicated chiller plant. The plant is generally going to have a high level of redundancy. So if you need one chiller, you'll have three. So you'll have the N plus the N plus 1 plus the N plus 2. You'll see the ability often for, they'll run scenarios for how are you going to deal with what happens if this pump goes out, if that chiller goes out, being able to run multiple combinations and multiple pieces of equipment. But redundancy is the most important thing that most of these designs are after. When you go into smaller data units, data centers, many of you probably have seen these. We do see the use of what are called computer room air conditioning units. We often call them Libra units, they're one of the manufacturers. Those units are now even getting integrated into the rack designs. You see companies like APC, which is Mary Schneider Electric, doing some very clever things with cooling in the racks. But generally larger data centers are not using crack units. They're generally using, like what I'm showing in the picture here, you'll have a system that consists of chillers and towers on the chiller plant side, and then in the server room, you'll have what they call a fan wall or a fan array. And what you're seeing here are entire walls of direct drive fans, no belts, they'll have, each one will have a variable frequency drive on each fan. But this is a really appealing concept because if you lose a fan, well, first of all, the fans don't have the issue of the belts, the shivs, and everything else because they're direct drive. And if you lose a fan, it's not a big deal because you've got this whole wall full of fans. And it's a very appealing concept for data center operation. We do see a lot of work that's gone on to improve the efficiency of data centers, particularly on the HVAC side. I mentioned earlier the use of the hot and cold aisles and air diversions. You'll even see people that are coming in and doing a lot of temperature measurement and what we call computerized fluid dynamics, CFD analysis to try and figure out where the air is going, how to divert it back, better set to be more effective. As I said, there's been a big mind shift of being able to run at higher temperatures. One of the drivers for this is the fact that most of, it used to be that owners or operators were worried about the equipment, but now the equipment's all leased, so they don't really care. They're going to run it until it dies. If it dies in 3 years or 4 years, whatever, it doesn't really matter. So they'll run the processors hotter than they used to. There's been a lot of work done to figure out what that need is, but we're seeing them running hotter and running higher. And frankly, what most folks have found out is that the processor is going to be obsolete, which happens pretty quickly, long before it dies of overheating. One of the big changes in data centers, which is a type thing, is that they've discovered that they can naturally cool data centers. So You see a lot of data centers being moved into northern climates because we can free cool them using an air side economizer or a water side economizer without having to mechanically cool them. And that's a big shift in data center design right now, to use natural cooling and economizers. And we even see use of more passive systems. There are people designing mobile data centers that fit in shipping containers that just run really hot, and that's fine.
Modular designs using
From
shipping
controls
containers are
perspective,
common too, or starting to be.
control design, just like everything else, has to be redundant. And I've seen a lot of designs where they want to see, multiple controllers and redundant controllers. You'll see a mix. There are some commercial control systems, and automated logic is one that I've seen in a couple of data centers, but also a lot of people are using industrial process control systems. The cost and complexity of the control system is nothing compared to the cost of a few minutes of downtime in one of these centers. And generally, you're going to have some type of control room that's going to bring everything together. So that's information on the HVAC system, on the electrical system, on the electrical switching, and then we'll talk about this in a minute, but efficiency criteria like the power utilization effectiveness, the PUE. It may even include things like some of the IT stuff, network traffic. Almost all of these data centers generally have a pretty small on-site staff, and they'll have a remote, what's called an operation center or network operation center that they can operate remotely. It's not at all uncommon to see situations where data centers are set up so that if they die, those automatically taken over and switched over to another data center in another part of the world or another part of the country. Data center efficiency never used to be an issue. It was because the application is so critical, but now it is. And the way that we measure efficiency in a data center is different than how we measure a data center in a commercial building. In a commercial building, we think about EUI and energy utilization intensity. In the data center world, they think of the data center efficiency, DCIE, but generally what they are measuring instead is something called the PUE, the power utilization effectiveness. And what this is a ratio of the total power being used in the facility divided by the power being used on the IT equipment. And it used to be, you'd see data centers that would have a PUE of 3 or 4. Now we're seeing ones that are approaching 1, which is 1 is the best theoretically possible that you can do. But we're now seeing things that are being done, particularly by some of the folks that are pushing the envelope here, like Google and Facebook and others, in the 1.2, 1.3, 1.4 range, which is pretty remarkable. We see a lot of focus, particularly by a lot of the big tech companies, for sustainability. They have large corporate programs and focus on being sustainable. So Google, Apple, Microsoft, Facebook. I was going to show you, Facebook was doing a whole series of sustainability initiatives on their data centers. In fact, they were doing experiments and actually publishing the results, allowing people to use their blueprints. They had 2 data centers where they were actually showing the PUE in real time, but interestingly, that's no longer the case, so they're no longer allowing you to see that. But here's a couple of things on this slide that you can see. The first is the continuous PUE from Google over time. As you can see, it's worse in the summer and better in the winter, not surprisingly. But their PUE now is in the range of between 1.1 and 1.15, which is pretty remarkable. The other picture is interesting. This is an experiment, I think it's an experiment that Microsoft did, where they took an entire data center, put it into a structure, sealed it airtight, and put it at the bottom of the ocean. And this is an example of a passive data center. It operates obviously without any people aboard, doesn't need any air on it, but it's naturally cooled by the ocean. And it obviously is going to get a very, very high PUE. In fact, it should approach a PUE of 1 because you don't have any need for anything else going on. The other issue with data centers, obviously, is they're water intensive. And this is a big issue, a very confrontational issue. So you do also see the use of water use effectiveness, WUE, which measures the water utilization and effectiveness of the data center. So I understand that you folks are going to do a field trip this afternoon, and you're going to go visit a data center nearby by Cyrus 1. I haven't seen this data center, and I understand that you'll meet with the facilities people, and they will go through some things, but here are some things that I would encourage you to try and figure out while you're there. I do know the answers to some of these, by the way, but just the things for you to figure out. But you know, is this an enterprise center? Is it a co-location? Is it a cloud center? What is its tier level? Is it tier 1, 2, 3, or 4? What is their current and historic power utilization effectiveness? How are they managing power and HVAC? And then I always think this is an intriguing thing, and Robert, I'm sure, knows the answer to this, but why would you put a data center in Omaha? What is unique about Omaha? And there is some interesting historical Cold War reasoning for why that's there. So that's the end of what I have for formal presentation. And I think we've got a few minutes left. If there's any questions, I can try and answer this for you. And Robert, will you repeat the questions for me?
Yes, I will, absolutely. I just want to say that we had really good attention here, and I think about the only one who was falling asleep was Bob, except when he was trying to heckle you.
Yeah, Paul, your voice is too soothing.
Your voice is too soothing.
That would be Bob. That would make sense.
Yep. So, what questions do we have? Peter?
So is there some legacy infrastructure from SAC headquarters?
So Peter is asking if there's some legacy infrastructure from the SAC headquarters. So I think you might have a different perspective on why data centers are coming to Omaha, which they really, really are, by the way, than I do. So I'd be curious.
So I think that was an answer, not a question. But yeah, my recollection, Robert, is that because of the SAC headquarters and the fact that Omaha is extremely central in the U.S., Omaha has historically had the best telephone and data connectivity of the country. So you see a lot of call centers that are based in Omaha, and I would imagine that from a networking and data center perspective, there'd be a lot of advantage in locating. And I understand that the center you're going to see today is actually the first open network data center, where you actually can choose which network, how you connect to the internet from the center.
That's an interesting concept for sure. And really, what's really, really interesting about this is it actually isn't so much the military that brought the connectivity, it's
Right.
Union Pacific Railroad.
Well, that makes sense. As I said, it's central, so all the lines cross when you went through there, right?
Absolutely. And the railroads were really amazingly forward-thinking when they created their leases for the railroads. They gave themselves enough space on either side. And so along just about every active commercial railroad track, you're also going to find an immense fiber optic channel for data throughput. They have some of the largest bandwidth data transfer capabilities in the United States. So.
Sure.
It's really interesting because when I was coming out, one of the things I noticed was all my credit card transactions took a lot longer than they did in East. Now, whether that's because most of the financial centers are in the East, or whether it's just that they haven't, whether it was the local equipment that was slow.
So
That was an interesting, it was just something I noticed.
Robin observed an interesting thing as he was traveling. He was one of the few who drove out here, that his credit card transactions got slower and slower as he came further away from the East Coast, and wondering if that was because of data transfer rates or just slow equipment. One of the interesting things is we have several credit card processing facilities that have their main main facilities here. First Data is one of them, and they have some immense data centers here in town.
Plus, Omaha has the advantage of having cold winters. centers, which, as I said, if we go to natural cooling for data centers, it is a big appeal to be in a place where you've got the ability to use cooler winter weather.
Inarguably. Our power here is also relatively inexpensive. It's not as good as it is in like Washington, Oregon, where you've got a lot of hydroelectric, but it is pretty affordable overall.
So where I'm from, I'm on the St. Lawrence River with the power, cheap power, hydropower, cold winters.
Yep.
And the only thing we're doing is crypto because there isn't the bandwidth.
Right.
Bandwidth limited there.
Yeah. So for those of you not familiar, most of the current cryptocurrency mining is a processor intensive activity, not a storage or bandwidth intensive activity. There are some weird exceptions out there in cryptocurrency, but for the most part, it's just crunching numbers and then sending very short spurts of data. So, someone had a question.
There's actually a lot of controversy about the use of data centers for cryptocurrency because it's essentially turning electricity into cash. So, I know when I had lived in the Northwest, there was a lot of interest in doing Bitcoin mining using the hydro, and some people that had some really hard feelings about that. So it's an interesting topic.
Absolutely. Question.
To reduce the carbon footprint portion of it, when you're exercising your gen sets, do you use that waste energy or basically electrical energy back into the system?
Great question. So the question is, Paul, when you, to reduce carbon footprint, when you're run testing your generator sets, do you utilize that power or re-inject it back into the grid, or is it wasted power?
Generally, because of the need for uptime, what you'll find, and this is very wasteful, what you find most data centers will have is there's many different ways you can test your generators. You can just test them and run them, but most critical applications, they're going to want to test them under load, and they actually will use a resistance bank, and they'll just burn that power off.
Yep.
This is just a giant bank of heaters,
Yep.
and it goes there outside. It's probably something that can be used more effectively, but generally you only do a test under load periodically. So.
Yep. Also, here, at least in Omaha, one of the things that will happen is as big storms and severe weather starts to blow in, a number of our big data centers like Google, Facebook, and Yahoo will actually pull their data center off the grid and start running on generators preemptively so that they don't have to shock their system and risk a failure because of a local lightning strike or power outage, something like that.
Yeah, although keep in mind that their systems are pretty well conditioned too. So if you're running on, V-Day and it fails, they can immediately change over. And they do generally have enough in terms of a short-term EPS that they can easily get through those glitches. So.
Absolutely. It's some of the people running the centers around here are maybe a little extra paranoid. We'll put it that way.
Well, and when uptime's everything, it doesn't hurt to be paranoid. So.
Absolutely. And with some of these data centers, when we talk about uptime and the cost of downtime, most of these medium to large size data centers are measuring that downtime in a cost of millions of dollars per hour.
Right. But they are also designed in a way that they can fail over. So that's the good news. And you'll also see, even when you go out to the site and look at their generators are set up so that they start instantaneously. So the generators are always hot, they're always ready. And there's actually, on the tier criteria, there's a thing that talks about how quickly the generator has to be able to start and spin up and take over load. And they're incredibly fast. So.
Peter.
Is anyone tracking how many data centers there are nationally and globally and what their carbon footprint is, what their power consumption is?
Paul, do you know if anybody is tracking either on a national or global level how many data centers there are, what their carbon footprint looks like, what their energy footprint looks like?
I know that a lot of there is a lot of tracking. There are various different roundtables and organizations involved with this. I'm not intimately involved with it on a daily basis, but I know that there is a lot of that goes on. You'll also see reporting on this that goes on through organizations, including things like Energy Star. They started to report on it as well. The tech companies almost all have their own pretty detailed, publicly available sustainability reporting. So you can go, for example, on the Google site under sustainability and see what they're up to and how much energy they're using for data centers. That chart I showed you is from their site. So they are reporting a lot of that. And many of the tech companies, particularly companies like Apple and Google, they are, and Microsoft, they are very, very committed to a high level of sustainability. So they're in many cases purchasing a lot of renewable energy, and they're offsetting everything they're using in their data centers through renewables. Not necessarily using renewables on the data center because it's just too much capacity for what's available, but they are owning or purchasing a lot of renewable energy or renewable credits in order to offset what they're using in those areas.
Thank you, Paul.
I had heard a number recently, it was 5% of the energy of the grid, electric energy is going into the data centers.
Okay. Ted heard a statistic recently that said that something like 5% of power produced is going into data centers.
Could very well be. You need to look at that globally though, because we have less energy being used in the U.S. today for primary industries like steelmaking, for example. There's more being done overseas. We're doing more data centers here, so things have shifted around. We do less loader smelting than we used to. So a lot of that energy use has shifted. So.
Makes sense. Other questions?
Hey, Robert?
Yes, Larry.
Has anyone asked if there's a way to recapture any of the waste heat?
Paul, do you know if there's anybody working on ways to recapture the waste heat out of a data center?
There's a lot of interest in doing that. The challenge is how you're going to use it, where are you going to use it. The truth of the matter is most data centers are built relatively remotely, and the waste heat is relatively low quality, so it's a hard thing to reuse. But yes, there is interest in doing that.
Just very challenging to try to accomplish.
It's very challenging because if you're coming off your hot aisle at 85 degrees, that's not a high level of waste heat. You couldn't make steam from that, for example. So it's just hard to get use of that heat. You need some kind of a process that you could use that's pretty close by because it's not real high temperature. It's not easily transmitted. So, but there is interest in trying to use that as effectively as possible. Yes.
Other questions? Peter.
Yeah, I'm not sure, Paul may have explained this, but what do you put in the hot aisle and what do you put in the cold aisle?
Okay.
And what differentiates the two in function?
Hey, Paul, can you elucidate a little bit further on cold aisle versus hot aisle? What goes where, kind of that whole picture a little bit?
Sure. So if you think about, the easiest way to think about a hot and cold aisle is to think about your desktop computer. So if you think about a desktop computer, which is how all this started, inside it's got these little box fans, and it's pulling air in, and pushing that air over the processor and the other electronics to cool it off. The air comes in generally comes in from the front and it goes out the back, or the other way around, which doesn't matter. So the concept of a cold aisle is the side of that rack that gets the colder air. So that air might come in at 55 degrees or 65 degrees, and then you want to force that air through the rack and cool all the electronics. And when it comes out the other side, it is the temperature coming off the processor might be 140, 150 degrees, but that air on average is going to be much hotter. So generally that return aisle, the backside of that rack is going to be pretty hot. And when you go through the data centers, you'll see this. When you walk in the hot aisles, they're generally uncomfortably hot. And when you walk in the cold aisles, they're generally uncomfortably cold. It's a miserable place to be. And frankly, there's almost never anybody there, because there's no reason for anybody to be in the racks generally. They used to come into the racks to change out gear, and sometimes they'll still do servicing there, but more often than not, they roll a rack out and they roll a new one in, plug it in, and go. So keeping it comfortable for people is not an issue.
Sorry, I was just doing a quick drawing on the board to help explain as you went.
No, thank you. The other change in data centers is, you used to see a lot of push for a lot of humidification. And any of you who've worked on computer room air conditioning units, that they contain humidifiers. That seems to be less of a priority than it used to be. The whole concept that your data center had to be, 65 degrees and 50% humidity is kind of thrown out the window. And the realization now is that that's much less important. I did do a project once for a large IT company, not actually the data center, in the lab, which is an area where they were testing the equipment. And we came in and reduced the humidity levels. I think we reduced their energy use for HVAC by 25%, because the energy use for humidification is incredibly high. It's just a very efficient process. And the owner said, well, doesn't the humidity have to be 50%? I said, well, your own documentation says it has to be 10%. You're fine. And it worked fine with them. So.
And correct me if I'm wrong, Paul, but the reason they were so heavily concerned about humidity was static electric buildup, correct?
So the reason they were, Robert, you're absolutely right. So the whole concern is about what's called anti-static protection. And most data centers will have a special anti-static system as part of it, which includes things like anti-static floor coverings and mats, but it also includes a whole series of anti-static procedures. So for example, if a technician is working on a piece of equipment, they have a wristband that they put on and it clips into the rack, so that they're grounded, they're not going to get a shock to anything. If they follow those procedures, the static isn't a big issue. And as I said, there's rarely anybody in there anyway. So the equipment doesn't care if it's moist or not. The technician fooling with it does care. But through the correct anti-static procedures, they can help prevent that from being an issue.
Within reason.
Oh, I'm sorry. The other reason they used to care a lot about it, Robert,
Yes,
is that they used to do a lot of printing in data centers. So the banks would print their credit card statements and things, and printing cares a lot about humidity. So that was a big issue when you were doing a lot of printouts, but we just don't do that much with that anymore.
yeah, makes sense. Other questions? Peter?
The study that we did back in 2012, are those best practices still quite relevant today? Care to comment on that, Paul?
So Peter's question is, with the study that we did on the eBay unit back in 2012, there were a lot of best practices that were noted in that. Are most of those still relevant or mostly irrelevant, or where would you say we're at?
I would think that they're mostly still relevant. I mean, most of them are about good operating practices to make sure that things are operating properly. In terms of efficiency, eBay was kind of ahead of the curve on a lot of folks for what they were doing. So yeah, I think that's what it is.
Perfect, thank you. Other questions? All right, I think we're out of questions for now. Paul, do you have any closing remarks you'd like to leave us with?
I wish I was there with you guys. It'd be fun to go ahead and see the center. But I hope you guys are having a great workshop, and I'm looking forward to seeing the results from how it goes. So thank you so much for having me be involved.
Thank you, Paul. Thank you again. Have a great day, sir.
Thanks, man.
All right. So yeah, just a couple of quick comments. The hot aisle, cold aisle thing, that is, on the scale of things, a fairly recent development for data centers. Some existing data centers are adapting to it because they realized how much money they were spending and wasting on cooling air that really wasn't cold or wasn't warm to start with. So it's much better for the heat transfer, the chillers are happier, all of those kind of things, so it runs more efficiently. And overall, the idea is that you would have, some methodology to separate physically your server racks, and you would blow cold air in the front and let it come out the back. And that would be where your return air would process through. That way, all of your air is passing through the server racks, picking up as much heat as it can, and you're not re-cooling already cold air. You're not wasting that fan power. You're not wasting that cooling potential, things like that. And in most, there are physical separations that help aid that. Sometimes they're fiberglass walls, or not fiberglass, plexiglass walls, things like that, so they don't reduce visibility, things like that. Russell?
In our college's data center, it's probably about as big as this room is right here, and we have hot and cold air, so our supply air is coming out on the floor. We have it separated where our hot aisle, that's our return going up through the ceiling,
Yep.
turning back to our track units and stuff. So that's how we produced our cold air aisles and our hot aisles in our data center where we separated the supply and the return from floor to ceiling.
A very common way to do it, especially if you're retrofitting an existing data center. One of the interesting things related to hot aisles and cold aisles is there is debate within data centers as to whether you do cold aisle isolation or hot aisle isolation. And it's basically where you're putting your walls and separators, so that do the racks, is the rack here, do we put the wall on the front of the rack so we force the air that way, or do we put the wall on the back of the rack so that the smallest area is the hot or the smallest area is the cold? Kind of an interesting analytical discussion. I don't think there's a solid best practice related to that one yet. But
Just one other thing you should really mention is how you get the cold air and the hot air to that spot.
mm-hmm.
And they usually come through the raised floor,
Yep.
which means the bottom of the area below the floor needs to be sealed very airtight, because you don't want that air going out in the rest of the building. And so basically do a smoke test and verify that there isn't any leakage there. And it also has to be, conditioned or insulated basically, or conditioned so you're not wasting or condensing water down in that area.
Absolutely right.
Other problems.
Correct.
And plus, that's where all the cabling usually goes too.
In many cases, yes. So in your average commercial building, we've gotten really used to using above ceilings as our return air plenum. And that's still very common in data centers. But what they've done is they've also lifted up the floor and created a plenum underneath that they positively pressurize with the cold air being supplied. So that's what we're talking about when we say a raised floor. It literally is a raised floor. Most of them, from the ones that I've worked on, the raised floor is about 2 feet of plenum, which makes doing work in it not the most pleasant. So I'm not saying they're all that way. Big data centers probably use larger plenums. I don't. Ted?
What about, this is all air, what about liquid cooling? Is there any shift to that?
No. It's too hard to implement with the density that we've gotten to with the servers. And this is kind of back to Paul's point that we've changed over from the traditional computer in a box,
Right.
kind of, what we normally think of as a server that mounts in a rack, to literally lines of servers that stick into a card or into a back plate that provides that that blade network connectivity, and power. So it's literally plugging in like an old PCI or ISA card into a computer motherboard, except they're all individual computers plugging in, and you can have racks that'll, or cases that will hold 48 computers in what used to be a single server that was, you know, about this wide and about this tall, and about that deep. So, with liquid cooling, it's just not practical to try and direct cool like that because of the density. Also, with liquid cooling, you also have to be really careful again about condensation. So, challenging. Bob?
I was reading an article that said that even though we've massively grown with all our data centers, it was such a train wreck of old inefficient crap before that, you know, the efficiency level is kind of leveled that playing field, how much energy they're still using. So the same amount, but that's all.
Yeah.
Bunch of energy pigs they were before.
It's a fact. I mean, look at the energy levels that we've gained, or the power versus energy consumption we've gained just in our consumer level electronics. So, last comment.
To follow up on the question before, essentially, rack design has changed greatly in the last 20, 30 years, basically. And that's what poses this hot and cold aisle kind of deal. Because it used to be the old racks used to put that fan on top of the rack.
Yep.
And pulled in, and of course, all the processors that, you know, were on the top got soaked with heat from the freezers, all the ones before. And, you know, somebody had a bright idea and said, yeah, that doesn't work. So now we would do a cross flow, and then I got the idea, hey, now we can serve vertically, you know, to get better heat transfer.
Absolutely.
Then they'd never match it, the airflow would be different.
Yep. Yep.
Then you circulate the same air inside the same cabinet.
Once again, back to that problem with IT,
Yeah.
right? It also used to be that the server racks themselves were a very fixed device. Floor to ceiling, it would bolt into the floor, it would bolt into the ceiling and just tick, tick, tick. But now everything is more designed to be that plug and play, get it in, get it out when it's not working.